So our fourth lesson is solving equations in one variable, meaning equations meaning that we've got something involving an equal sign, one variable meaning that we're only dealing with like just an x or just a y. There's not like two different variables to solve, which can be much harder. So we're going to start there. So just to be clear, an equation or inequality that contains a variable such as, like, notice here's a variable and here's a variable, that they each have one variable. Another name for those is called an open sentence. So it's an open sentence because really, like, we're not sure which value is going to go in there. So we talk about, like, well, what is x? What is t? When we talk about those, we say any value of the variable that makes it true. So like when we plug it in, we figure out what that number is supposed to be. We can call that the solution, root, and it's said to satisfy it. I say that because these are all going to be terms that you're going to see on the tests and quizzes, like what satisfies this equation. You need to understand that that means what is the number that makes this true. Sometimes it'll just be one number. Sometimes it could be a lot of different numbers. For example, sorry, when we're looking at 2t minus 1 equals 5, if we were to go through and figure out what makes it true, 2t minus 1 equals 5, how would I go about solving that? Like, what is my process? Yes, sir? Add 1 to each side. So when we move it over, I'm just going to be a little more technical because how did it get there? I added 1 to get rid of the negative 1. I add 1 over here. I get 2t is equal to 6. Since that's 2 times t, I'm going to divide by 2, and we get t is equal to 3. So that's what we get this next part here. It says 3 is a solution of 2t minus 1 because 2 times 3 minus 1 is 5, which is true. If you were to plug in any other number there, they would not be a solution. If you plugged in 5, you would get 2 times 5 is 10, minus 1 is, like, let's plug in a different number here. We've got 2 times t minus 1 equals 5. I'm going to pick anything but 3. Let's pick, 4. 2 times 4 minus 1 equals 5. That's 8 minus 1 equals 5. We get 7 is equal to 5. That is not a solution there because that is not a true statement there. So we know by plugging that in that that is not a solution. However, sometimes things have more than one solution. You've dealt with things that have more than one solution when you factor, and when we get into inequalities, you'll see that there can be an infinite amount of things that will make something true. So the set of all solutions of an open sentence that belong to a given domain of the variable is the solution set. So sometimes there'll only be one answer, but sometimes there'll be tons of answers. However many they are, they're a part of the solution set. So we're going to be looking at those right now. If you notice, when we talk about x plus 3 is greater than 0, how would I go about solving that? By the way, it's no different than what we just did. Just because there's a greater than sign, it's no different than what we did before. Well, I've already got a plus 3, so you're close. Not plus 3. Okay, I'm going to subtract 3 from both sides. And what this tells me is that x needs to be greater than negative 3. Any number that is greater than negative 3 will make this true. Any number in the world. So use negative 2, use negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, anything all the way up to infinity. As long as that number is greater than negative 3, it will make this statement true. So you can see in the first one, we only had one number that made it true, whereas the second one, there are an infinite amount of numbers. So it's not always just one. This is usually a good sign that there's something different going on when you see a greater than, less than sign. And you're going to see that in today's homework and on the test. All right, so we're looking for things that are true. And so let's say that we've got two separate equations, like 7x plus 12 equals 47. Let's take a look at that for a minute. 7x plus 12 equals 47. 7x plus 12 equals 47. Hook me up. Walk me through that one. Where am I going with that? Okay, let's subtract 12. Subtract 12. And we get 7x is equal to 35. And then divide by 7. And when we do that, we find out that x is equal to 5. So 5 is the number that would make this true. However, sometimes we get to other things like just a statement, a simple statement like x equals 5. Those are the exact same things. Those two things, 7x plus 12 equals 47 and x equals 5, are the exact same thing because they have the exact same solutions. So something as simple as just x equals 5 is an equation. It doesn't take much work to figure out what x is. It already says x is equal to 5. So those two things are the same. So we would call those equivalent equations. To solve an equation, you usually have to change it or transform it. You move things around, and that's what we're going to be playing around with today. Transformations that produce equivalent fractions. So we're going to simplify. These are our steps. We're going to simplify either side of the equation. We're going to add to or subtract from each side of the equation or the same expression, and then we're going to multiply or divide. So the same steps that we were just doing right there is that we're going to go and simplify anything that can be simplified. Our number one step is there anything that can be simplified from the start? So I'm going to look at example 1 here, and let's talk about what can be simplified. I don't want to move things. Nothing's going to change sides yet. But what can be simplified up there? So inside the parentheses? So 2x minus 9, how do I do that? You're close. You're real close. I could distribute in that parentheses. I could do that for sure. That's math that can be done on this side. So I like to call simplifying is like the math that can already be done on one side. So 5 times 2x is 10x. And 5 times negative 9? Negative 45. A positive times a negative is a negative. And notice we're done with step 1 now. We have done any simplifying. There's nothing else on the left to be combined, nothing else on the right to be combined. Step 1 is done. Now we are going to add to or subtract from each side of an equation the same number, the same expression. So notice that I've got x's on both sides. Now you can do whatever you want. Some people learn it that you always have to have the x on the left. You can never have the x on the right. That's not true. You can put the x wherever you want. You can put it on the right or left. But I'll tell you something that I have found, and I'm going to tell you right now, like if you don't get this about me, I am a guy who didn't like math when I was in high school. No joke, I didn't like it. I was in the same place as a lot of other people. And I was like, I got to find what makes my life easiest in every situation. I'm not trying to be like the next, engineer to launch a satellite into space. All I'm trying to do is get through this math. And for me, I found that every single time, like when I look at 10x and 7x and I decide which one of those things I want to move, I have found it always worked out easier for me if I move the smaller one. And here's why. If I move the big one, I'm going to end up with negative x's. Like I'm going to have if I decided to subtract 10x, I would have 7x minus 10x, and it's always going to put me in a situation where I'm dealing with negative x's, and I don't want to do that. So 7x and 10x, I see the 7x as smaller, so I'm just going to subtract that. You can use this strategy if you want. I'm only suggesting it to you because I'm trying to make your lives easier. So we get 10x minus 7x, which is 3x. We get 3x minus 45 is equal to 60. Where do I go now? I certainly would add the 45. So I'm going to add 45. Was it negative 60? You're right. I'm sorry. Negative 60. Thank you. And a positive 45. So negative 45, positive 45, that ends up as 0. So we get 3x is equal to, now negative 60 plus 45. I'm adding two things that have different signs. Is that answer going to end up positive or negative? It's going to end up negative, and then what do I do with the 60 and the 45 to figure out what number it is? Subtract. 60 minus 45? 15. So now we're at 3x is equal to 15. Where am I going from there? Divide. I'm going to make a mistake right here. Catch me on it. X is equal to 5. It's negative 5. And that's the difference between a right and a wrong answer there, is that was a negative and a positive. So when we divide a negative and a positive, we get a negative number. I'm just going to clean that up a little bit. All right, so there was our first one. Let's go on to example 2. Remember, same thing every time. My first step is going to be Doing my simplifying, aka do any math that you can. So of course, we're going to follow our order of operations that if there's anything to be done in the parentheses, we should do it. If not, don't worry about it. If you can't do what's in the parentheses, move on. So can we work inside either of those parentheses? No, we can't add x's and like whole numbers. They don't work that way. So what should I do? Let's distribute. I'm just putting this on the bottom here because I'm not going to be able to see the arrows on top. So we get 6x minus 9 is equal to, let's distribute here as well. We get 6x plus 6. Ooh, this is going to be interesting. Minus 10. All right, again, I'm not going to start moving anything until I've done all the math that needs to be done on both sides. Is all the math that needs to be done on both sides done? No. Where's there math to be done? 6 minus 10. 6 minus 10 is? Okay, so we get negative 4 there. So we get 6x minus 4. And over here we have 6x minus 9. 6x minus 9 is equal to 6x minus 4. All right, so what do we want to do? Let's get our x's to one side, our numbers to the other side. Let's subtract 6x. I just chose this one because most people seem to like it on the left. So that's interesting. I ended up, those 6 x's are gone, and now all I'm left with is negative 9 is equal to negative 4. That's a weird statement. What does it mean? Because now I got here, and I got to something that, like, not in math nerd speak, in real human speak here, should be like, that's weird. That doesn't normally happen. So what does that mean when we get to negative 9 equals negative 4? Is that true? Is that negative 9 the same as negative 4? Okay, so they're not equal, which means there is no solution to this. Now, I'm going to tell you right now, when all your x's disappear, you're going to run into one of two situations. This is one of them. And we're going to see the next one in just a moment. So this is very important because I'm starring this because when I star things, it means that when you see this, you could see this again. So all the x's are gone, and we are left with something that is not a true statement. That is no solution right there. No number in the world that you put in here will make this true. All right, I'm going to slide over to example B over here. This one is going to be another interesting one because something weird is going to happen. So I'm going to start in the parentheses. This one actually looks very similar to the last one we did. I'm going to start inside the parentheses. Anything to be done there? Okay, so where do I go from there? Let's distribute. 3 times 2x. These look like almost the exact same numbers here. 6x minus 9, but something is a little bit different over here. Nothing to be done in parentheses, so I will distribute. Is equal to 6x plus 6 minus 15. So now that we've done that, is there any math to do on either side? The 6 minus 15, what does that give me? That's this right here. Okay, negative 9. So we get 6x minus 9 and 6x minus 9. Okay, so what are we going to do? Yes, sir? Leave it. We could leave it, but let's get it down to like as simplified as possible, like as finished as possible. You're right that like some people know how to interpret that, but let's keep going to as simple as possible. Okay, so let's subtract 6x from both sides. 6x, 6x. Again, they're gone, but this time we're left with a different statement. Negative 9 is equal to negative 9. Now a moment ago, we saw when negative 9 was, when we ended up with negative 9 is equal to negative 4, we knew that wasn't true. Those are not equal, and we got no solution. So what do you think this means? It's what? It's a true statement, so what number could I plug in that would make this true? Okay, just 1? Is that the only number? So here's the interesting thing. The answer to this is almost like the exact opposite of the one we just did. You can plug in any real number, any number you want, and it'll make this true. So what we get is we write our answer is all real numbers. And if, in case you're like, wait, what? I don't get that. Let's go back to the original statement and just pick a number. I'm not going to do anything to just make up a number. I'm going to pick 3. Okay, 3, because I'm trying to keep my numbers low so I don't make my things really big here. Every time I see x, I'm going to plug in a 3. So on the left, in the parentheses, I get 2 times 3, which is 6, minus 3. That leaves me with 3. So 3 times 3 on the left. On the right, I got to work in parentheses, and I get 3 plus 1 is 4. 4 times 6 is 24, and 24 minus 15 is 9. So we get 9 is equal to 9. No matter which number you choose, as long as you are using real numbers, and some of you are like, what do you mean real numbers? That's because we will, in this class, get out of real numbers into different sets of numbers that you have never worked with before. So we're going to get into the imaginary realm and those imaginary numbers, but for right now, we're dealing with just real numbers. So you should know the difference as to what it means when two things make a very logical statement, like -9 is equal to -9. That's going to end up as all real numbers. If it had ended up as 4 equals 4, that would still be all real numbers. 0 equals 0, all real numbers. 187,000 is equal to 187,000, all real numbers. But when we got to a statement that was not true, that's no solution. No number that you can put in there will make this true. So you're going to have to be able to tell the difference between those. All right, a couple more examples here. What stinks about this one? The fractions. I think we all agree that if we could get rid of those fractions, this would be easier, correct? Like if this had no fractions at all, if we were just dealing with the numerators, this would be a lot easier, yeah? Like we'd all feel better about it? I agree too. I have that same hesitation you do when I see these that I'm like, ugh, that stinks. So here is a great way to turn all of your fractions into something way easier to work with. So what we're going to do here is notice that I have all fractions. They're all fractions, like just a terrible situation there. I'm going to put parentheses around them. And here's what I want to do. I want to find a number. I don't care what number you pick, but I want to find a number that I'm going to say 3 of those numbers. I know there's 4 denominators, but 2 of those numbers are exactly the same, right? 3 is the same as 3. So there's like 3 unique numbers up there. There's 3, 2, and 4. There's another 3, but there's only 3 unique numbers. I need a number that both 3, 2, and 4 all go into. 12 is a great number. 3 goes into 12, 2 goes into 12, 4 goes into 12, and I am going to multiply everything up there by 12. This is a great trick for dealing with these. If you're the kind of person who does not want to deal with fractions, here's how you get rid of them. Let's cancel some things out here. So let's start here. How many times does 3 go into 12? There's still 4 left over, so we've got 4 times 3x plus 4. Plus, how many times does 2 go into 12? 6, so that's gone, and we've got 6 times whatever was left in the numerator. That's an x there, sorry. There's 6. How many times does 4 go into 12? Okay, that's gone, and we get 3 times the 1 that was left over on the top. Minus, how many times does 3 go into 12? 4 times, so we've got 4 left over times 7. So notice, whatever I had left over, if 3 went into 12 4 times, that's where that 4 came from right there. 4 went into 12 3 times, that's where that 3 came from. 2 went into 12 6 times, that's where that came from, and 3 went into 12 4 times. Otherwise, the numerators have stayed basically the same. Well, I don't know about you. There's still a lot of work to be done, but this looks way easier. I forgot this x right there. I forgot to write that x. I think this looks way easier than the first situation. I would rather do this. So there's some things up here that are easy, and there's some things that are harder, but let's start working left to right. So let's do this. Let's distribute. 4 times 3x is 12x. I'm going to change colors just to show a new step. 12x. 4 times 4 is 16. plus 6 times 1 times x. 6x. 6 times 1 is 6. 6 times x is 6x. 3 times 1 times x. 3x. And finally, negative 4 times 7. Negative 28. Well, now we're to a way easier statement here. That's certainly way easier. Is there any math to be done on the left side or the right side? Yes, sir. Okay, on which side?
On the left side.
On the left side, what are we combining?
12x and 6x.
And what do we get?
We get 18x.
18x, and we still have a 16 over there. So we just combine these right there. 18x plus 16 is equal to anything to be combined on the right? Yes, no? No. Okay. No math to be done on the left, no math to be done on the right, nothing to like simplify those. So now we can start moving things. What do we want to move? Let's minus 3x. That's the smaller one. So minus 3x, and we get 15x plus 16 is equal to negative 28. All right, what's our next step? All right, I would subtract 16 as well, and subtract 16. So we've got 15x is equal to negative 28 minus 16. I do this the long way because this is the area where most people are making their mistakes, right there on the right-hand side. So I'm going to deal with that right there. I hate subtraction, so I'm going to turn that into addition. Negative 28 plus... Now I have to change that into the opposite number, negative 16. So I've got two negatives. If I were to add them together, would I get a negative or a positive? Yeah, two negatives, you add them together, you get another negative. It's going to be very negative. And then what do I do with the 28 and the 16? We add them together, and that will give me negative 44. 15x equals negative 44. Where am I going from there? Divide by 15, divide by 15, and we get x is equal to negative 44 over 15. Don't bother going to decimals. A lot of time people go to decimals. If it didn't ask you for a decimal, don't do it, because actually that's more work for you, number one. And number two, if you made a mistake along the way going to that decimal, then that counts against you. And we don't want that. Let's zoom out a little bit for those of you who are copying down stuff. All right, let's try another one. All right, where do we want to start? Let's distribute. 3 times 2x? 6x. 3 times negative 4? Negative 12. What about this one? What does all this mean? Exactly, great. He said, can't you multiply the negative, meaning can't we distribute this negative? That's like a negative 1 right there. That negative is applied. When you see a negative outside of parentheses, that means that negative goes to each thing on there. So there's a 7, and then a negative 1 times x is just a negative x, and negative 1 times 5 is negative 5. So all I did was bring that negative to each one of those two things. All right, on either side, is there any math to be done? Which side? The right side. Which math can be done over there? Okay, let's take 5 from 7. 7 minus 5 is? 2 minus x. All we did right there, 7 minus 5. Keep going, you're on a roll. Okay, good. Let's add x to both sides to get rid of this. Introduce it over there. We get 7x minus 12 is equal to 2. What's next? Add 12, add 12, and we get 7x is equal to 14. Then divide both sides by 7, and x is equal to 2. Perfectly executed. All right, I think we just have a couple more. And these are actually some of what I think are the easy ones. But these are the ones that people like, here's what's going to happen. On Thursday, I'm going to give you your test, and these are the ones that people are going to go, what does this question mean? And I'm going to be like, I can't explain that to you, but I can explain it to you right now, but not on test day. So it says, solve the equation for the given variable. And notice what this says here. It says, A is equal to 1/2 B times H, and then it's got this semicolon and an H. What that means is, get H all by itself. So they're saying you don't have to plug in any numbers, you don't have to do anything except for get H all by itself. So that's what we're going to do. We're going to pretend that H is the thing we want all by itself. So let me just start here. Area is equal to 1/2 of the base times the height. That's how we find the area of a triangle. But let's get H all by itself. What's the first thing I can do to get H by itself?
Reciprocal fraction.
Okay, so what he's saying, that's exactly what I would do too. So he's saying, if you want that fraction, that 1/2 to get rid of it, then multiply both sides by the reciprocal. Take that fraction and flip it upside down and multiply by that number. Why? Because the 2 gets rid of the 2 and the 1 gets rid of the 1. But now you have to do the same thing on the other side. Multiply this side by 2 as well. So I'm just going to rewrite. We got 2 times A is equal to B times H. We're certainly much better, we're much closer to getting H all by itself. What else can I do?
Divide by B.
Divide by B. If I divide this side by B, the B's are gone. And if I divide this side by B, I end up with H is equal to 2 times A divided by B. So why is this important? Because like, let's say that you're given, like when it comes SAT time, you're given a formula like area equals 1/2 base times height, but they give you the area, they give you the base, but they didn't give you the height, then you could figure out the height just by getting height all by itself. Well, I want to know the height, then just take 2 times the area and divide by the base. So this is actually a formula that's very useful for you, especially when you're doing those tests here. This one's going to be a little more interesting. So we've got K is equal to 1/2 M times V squared. And notice here it's got that semicolon and then M. That means M is the thing that you have to get by itself. So solve for the variable, we want to get M by itself. It doesn't mean you need an answer of a number. It means get M by itself. So what do we want to do first? We've got K is equal to 1/2 M times V squared. What do we want to do? We got to get everything, we got to get M by itself. Yes, sir?
Multiply by 2.
Let's multiply by 2, or 2 over 1, because the 2 gets rid of the 2 and the 1 gets rid of the 1, so those are gone. But then I need to multiply the other side by 2 as well. 2K is equal to MV squared. Remember, all I have to do is get M by itself. Where am I going next?
Put the V on the other side.
How do I get the V to the other side?
Oh, yeah, negative.
Do what?
Make it a negative.
Well, so that's what we're looking at there is M times V squared.
Divided.
We got to divide it. So you have to undo whatever they did. That says M times V squared. We're going to divide by V squared. So M is equal to 2K divided by V squared. 2 more and then we're done, just like these. That's exactly what we're doing. But if you're seeing 4 examples of this from this section, you better bet that you're going to see this again. I certainly wouldn't take this kind of time to do this if it weren't going to be something that you're going to see. All right. One is equal to P times R times T. And T is the thing that we need to get by itself.
Could we simply just divide PR?
I'm so glad you said that. I was hoping somebody would say it. Here's what he's asking. I want to get T by itself. Instead of doing this in 2 steps, that's P times R times T. He's saying, can I do that division in 1 step? Like, hey, can I divide P and R in 1 step? Yes, you certainly can. Save yourself that time. Boom. Why do it in 2 steps? If it's 2 things that are ultimately going to end up over there, then we get T is equal to 1 over P times R. That's P times R times T. So I need to divide P and I need to divide R. So there we go. Do it in one shot. One more for those of you who are falling asleep on me. A is equal to P times 1 plus R times T, and we need to get R by itself. So this is harder to work with because there's a whole mess of stuff going on. But if I were to do a little math first, this might be easier. And I'm not talking about plugging in numbers, like doing the same things we've been doing on almost every problem. Let's try distributing, because right away that looks like a hot mess to work with. So let's distribute. So we get A is equal to P times 1 is just P. And then P times R times T, so there's a plus there, is P R T. All right. So remember, R is our goal. So what's the very first thing we can do? Let's talk about this. Remember, like we're gonna get rid of we're gonna do our addition and subtraction first. How can I get that P? Subtract it. And we get A minus P is equal to P R T. I'm so glad we're there, because actually now we look just like the last problem we did where we ran divide by P and not P and R, because we're trying to get R by itself. So we're dividing by what? P and T. P and T are the two things that are being multiplied that we want to move over. So let's move them over. P and T. So we get R is equal to A minus P over P times T. Now I'm going to show you another way that this can be written, and this is something we did yesterday in case if you ever are at a multiple choice test, you could see this written a different way and it's the exact same thing. Remember yesterday I said that this is one fraction here and here is another fraction right there. So what I'm going to do now is I'm just going to separate those. Here's another way that exact same thing could be written. A over PT minus P over PT. Notice both of those things still have the same denominator. There was an A over PT minus a P over PT. Same exact thing. These mean the exact same thing. Why do I show you that? Because honestly, some of you are literally going to be taking the SAT, which will decide your college futures. And I go, I would like to show you that, because if you don't understand that those two things, that could be the difference between a right or wrong answer. It could be the difference of whether you get into the college you choose or not. So I'm going to help you out there.